Okay, so let's do some actual density problems. But first, we're going to find the density of this brick. Um, well, density is mass times volume, and you're going to do word problems, and they're going to give you mass and volume measurements, or you're going to have to use that information to figure out mass or volume measurements. In this case, if I want the density of my brick, wow. Well, mass of this brick is about, I'm keeping the numbers a little round, the mass of this brick is about 2,200 grams, which by the way is about 2.2 kilograms. Pretty heavy, okay? That's about 5 pounds. And if I want the volume, well, I don't know it. I might be given information about the length, the width, and the height in a word problem. It may say, hey, you have the length, width, and height. For us, I'm going to tell you that the length, width, and height has these values. I just measured it. I rounded a little bit, but now in a word problem, it could say the length is, the height is, the width is. And you're going to have to calculate the volume. Well, if I do volume from math class, length times width times height, and that's going to be 19.0 times 9.0 times 5.5. And if I calculate all that out, so 19 times 9 times 5.5. I'll do that again. I got 940.5. Try that again, make sure I got that right. 19 times 9 times, okay, 940.5. Now, I should probably round that at some point, but because this has 3 numbers, this has 2 numbers, that has 2 numbers, so this should be, an answer should be have 2 or 3 numbers in it. That's a concept called sig figs, significant figures, which we're not going to get so into in this class, but it's just good number sense, right? This had 3 spots, this had 2 spots, this had 2 spots. This number should have 2 or 3 spots, but right now it's 4 spots. So it's not bad, but it could be better. Anyway, I'm going to keep it like this for now, but what I want to point out is this is centimeters and centimeters and centimeters. And when you multiply them, you multiply the numbers, you also must multiply the unit. So if I take centimeters times centimeters times centimeters, well, that centimeters times centimeters is centimeters squared. And if I do that again, it's centimeters cubed. It's kind of like when you multiply x in algebra, right? If you have x times x times x in algebra, well, that's x times x cubed. You have to do the same thing with units. You have to be aware of the units. Centimeters cubed. So I had to do a little bit of work to find that volume. Now once I have my mass and my volume, I'm able to calculate the density. You just plug it in and do the algebra. Density equals 2,200 over 940.5. Now, I know that some teachers like you to write the units in when you're doing the algebra. I don't, because I find that to be very confusing to my eyes, having all those numbers and letters together. But I must, in my head, know the units to those numbers. And so if I do this division, I get 2.33918. I mean, I get a lot of numbers. Two point three three nine one eight one two, like, and I don't even know if it keeps going or not, but listen, I'm not going to keep all those numbers. That's ridiculous. And some students are going to ask me, do I round? Where do I round? Do I round to the whole place? Do I round to the tenths, the hundreds? So listen, this has 3 spots of numbers. This has 2 spots. This has 2 spots. So pick 3 or 2. That means the 2 point, I got to keep that. Well, that's 1 spot. Now, if I write 2.3, and if I stop there, I got to make sure this 3 doesn't round it, and it doesn't. This 3 is lower than 5, so this 3 is going to stay a 3. I could stop right there, 2.3. Or, instead of 2 spots, I could go 1 more spot, and maybe this 9 rounds that 3 to a 4, and then I'd stop there and not look at the rest of that. I'll accept either. The best answer, according to the rules of science, which I'm kind of glossing over in this course, is to just keep it at the lowest amount of spots. So if this was 3 spots, this is 2 spots, this is 2 spots, then my answer really should be in 2 spots. When I get my answer, though, I need to realize that this is in units. It is grams. That was the mass. And the volume is centimeters cubed. So in this particular case, my answer is 2.3 grams per centimeter cubed. That's it. That's the answer for this particular problem. I'm going to show you another kind of problem in a second. So let's do another density problem. We're going to do the density of olive oil. And again, you got to know the mass and the volume to figure out that density. And in this particular case, I'm going to show you a bottle of olive oil. There it is, olive oil. And I happen to know from the package that this is a volume of 500 milliliters. So I know the volume already. It's there, it's a liquid. Now notice that's different than what we just did in the previous problem, centimeters cubed, but milliliters. Now, not to be too tricky, but remember, a milliliter is a centimeter cubed. So I could write this as 500 centimeters cubed. There's really not a difference. They're equivalent. I mean, some people would say that, use centimeters cubed for solids and milliliters for liquids. Anyway, in order to do the density, you need the mass. And I'm going to take my bottle and I'm going to put it on a scale. You're going to have to trust me on the mass here because you're not going to see it. Now, when I put it on the scale, it's 480 grams. It's a little less than that, but I'm going to round it. And yeah, the weight of the plastic bottle's in there a little bit. That's true. So we're not going to get a complete accurate density here, but just for argument's sake, if I were to mass that olive oil, let's say it's 480 grams. And so density is pretty easy. This one's straightforward compared to the previous one because you have everything easily measured, easily found. 480 milliliters, 500 grams. What? Whoa! I don't know what I did there. I totally reversed it. 480 grams, 500 milliliters. And then you do the quick division. And 0.96. And so 0.96. Not even, we don't even have rounding issues to deal with that. It came out pretty clean. And it's 2 spots. These are 3 spots. You know, it's close enough. If you wanted to be fancy, well, no, I'll just leave it at that. 0.96 grams per milliliter. Well, if I were to put this in with water, water has a density of 1.0. This has a density less than that. So the oil would, as we already know, will flow. Olive oil is going to float on top of the water. Again, that's your Italian dressing in the refrigerator. That's why you have to shake it. One more example. Okay, so one more. What's the density of that fishing sinker that I showed you earlier? Here it is. It's got an odd shape. And in order to do this, we need the mass. And I'm going to tell you right now, I put it on the scale, it's 60.0 grams. It's exactly 60. I put it on 2 different scales, it came up 60 exactly, 60.0 grams. So that's pretty easy, just putting on a scale. The volume, we have to figure out. But remember, doing the length times width times height of this could be difficult, and it could be even a weirder shape. It could be a round shape, whatever, but this is a weird shape. So one of the easier ways to find volume for weird shapes, for solids anyway, is to use the idea of displacement. So again, I started at 30 milliliters. I put this in. It rose to about 35. Now again, I could be a little more accurate, but this is a rough estimation. It's just an example. So the volume is, we went from 30 and we went to 35 milliliters. And I should really put, right? Well, what's the difference? I rose 5 milliliters. Mathematically, you would write that out as 35.0 liters minus, not milliliters, 35.0 milliliters minus 30.0 milliliters. That would be your 5.0 milliliters. And some textbooks will call that, V2 minus V1. Your first volume minus your second volume. What do you get? Some books will call that delta V. That little triangle means change or delta, and that's a subtraction. And so we find that. And once we have that, we can do the density. And that's a rough, rounded answer. The densities are around 12 grams per milliliter. Now remember, again, milliliter is also equal to centimeter cubed. So you could call it, instead of 12 grams per milliliter in a textbook, if I were to ask you to identify this metal, you would have to look up this density and match it with a known density of a metal in a reference table, and sometimes those densities in a textbook or a reference table might not be in grams per milliliter. Sometimes they're in grams per centimeter cubed. So you have to realize, oh, well, they're really the same unit. And this density, if you look it up, it's very, 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 very close to lead, because most of those fishing sinkers are in fact made of lead. So go ahead, Google lead, see what the density is.